Welcome to the crash course in Python. Whether you're a computer beginner or looking to refresh your Python skills, this course is designed to give you a fast paced introduction to one of the most versatile and in demand programming languages in the world. Python is renowned for its simplicity and readability, making it an excellent choice for beginners and experienced programmers alike. In this course, we'll cover the fundamentals of Python programming, including basic syntax, data types, control flow, functions, and more. By the end of this course, you'll have a solid understanding of Python fundamentals and be ready to tackle more advanced topics. Hi, I am Vivin Arana and I will be walking you through this crash course. What you'll learn: first, introduction to Python. Understand why Python is popular programming language and its various applications. Setting up your environment. Learn how to install Python and set up your development environment. Basic syntax. Explore Python syntax including variables, data types, and operators. Control flow. Understand how to use conditional statements and loops to control the flow of your Python programs. Functions. Learn how to define and use functions to organize your code and make it more reusable. Data structures. Explore built in data structures like lists, tuples, dictionaries, and sets and learn how to manipulate them. File handling. Learn how to read from and write to files using Python. Error handling. Understand how to handle errors and exceptions in your Python program. Introduction to modules and packages. Explore how to organize your code into modules and packages for better code organization and reusability. Introduction to Object Oriented Programming (OOP). Get an overview of OOP concepts in Python, including classes, objects, inheritance, and encapsulation. Who is this course for? It's for beginners with little to no programming experience who want to learn Python from scratch. It's also for programmers experienced in other languages who want to add Python to their skill set. It's for professionals looking to enhance their career prospects by mastering Python for various applications such as web development, data science, machine learning, and automation. So, in short, it's for everyone. What are the prerequisites? No prior programming experience is required. However, basic computer literacy and familiarity with concepts like variables, data types, and control flow will be helpful, even though we cover them in this course. By the end of this crash course in Python, you will have the foundational knowledge and skills to start building your own Python applications, whether it's simple scripts or more complex projects. Get ready to dive into the world of Python programming and unleash your creativity. Introduction to Python. Python is a high level interpreted programming language known for its simplicity, readability, and versatility. It was created by Guido van Rossum and first released in 1991. Since then, Python has become one of the most popular programming languages worldwide, widely used in various domains such as web development, data science, machine learning, automation, scientific computing, and more. What is Python? Python is a general purpose programming language, meaning it can be used for a wide range of applications. It features a clean and elegant syntax that emphasizes readability, making it easier to write and maintain code. Python's design philosophy emphasizes code readability with its notable use of significant whitespace. Why Python? There are several reasons why Python has gained immense popularity among programmers and organizations. First one is ease of learning. Python's simple and straightforward syntax makes it easy for beginners to learn. Its readability reduces the cost of program maintenance and development. Versatility. Python's versatility allows it to be used for a wide range of applications, including web development, data analysis, artificial intelligence, scientific computing, automation, and more. Vibrant community and ecosystem. Python has a large and active community of developers who contribute to a rich ecosystem of libraries, frameworks, and tools. These resources make it easy to find solutions to problems and accelerate development. Cross platform compatibility. Python is available on multiple platforms including Windows, Mac OS, and Linux, making it a portable choice for developing applications that can run across different operating systems. Libraries and frameworks. Python boasts an extensive standard library that provides modules and functions for common tasks. Additionally, there are countless third party libraries and frameworks available for specialized needs, such as Django and Flask for web development, NumPy and Pandas for data analysis, TensorFlow and PyTorch for machine learning, and more. Python applications. Python is used in a wide range of industries and domains, including web development. Frameworks like Django and Flask are popular choices for building web applications. Data science and machine learning. Python is preferred language for data analysis and machine learning tasks thanks to libraries like NumPy, Pandas, Scikit-learn, TensorFlow, and PyTorch. Scientific computing. Python is widely used in scientific research and computational science due to its rich ecosystem of libraries like SciPy and Matplotlib. Automation and scripting. Python's simplicity and versatility makes it an excellent choice for writing automation scripts and performing system administration tasks. Game development. Python is used in game development both for scripting in game engines like Unity and for building games using libraries like Pygame. Desktop applications. Python can be used to create desktop applications using frameworks like tkinter and PyQt. In summary, Python's simplicity, versatility, and rich ecosystem of libraries and frameworks makes it an ideal choice for both beginners and experienced programmers looking to develop a wide range of applications. Setting up your environment. Before you can start coding in Python, you'll need to set up your development environment. This involves installing Python on your computer and choosing a text editor or integrated development environment to write and run your Python code. In this section, we'll guide you through the process of setting up your Python environment step by step. First step, installing Python. Python is available for download from the official Python website at www.python.org. Follow these steps to install Python on your computer. So first, for Windows, download the latest version of Python for Windows from the Python website and run the installer. Make sure to check the box that says Add Python to Path during the installation process to make Python accessible from the command line from anywhere in your computer. For macOS, macOS comes with Python pre-installed. However, it's recommended to install the latest version of Python using Homebrew or downloading it from the Python websites. You can probably get the options from Homebrew website or from Python websites for installing steps. For Linux, many Linux distributions come with Python pre-installed. If Python is not already installed, you can typically install it using the package manager. For example, on Ubuntu, you can use command sudo apt install get python 3. So just entering the command on your command prompt inside Linux, you'll probably can get Python 3 installed. Once Python is installed, you can verify the installation by opening a command prompt or terminal and typing python dash dash version or python 3 dash dash version to check the Python version installed on your system. Second step is choosing a text editor or IDE. While you can write Python code using a simple text editor like Notepad in Windows or TextEdit on macOS, using a dedicated text editor or integrated development environment IDE can enhance your productivity and make coding more efficient. Here are some popular options. For text editors, you can use something like Visual Studio Code, Sublime Text, Atom, and Vim are some of the lightweight customizable options, making them suitable for writing Python code. For integrated development environment or IDEs like PyCharm, Spider, and Idle provide advanced features such as code completion, debugging, and project management tailored specific for Python development. Choosing the text editor or IDE that best suits your preference and workflow is the best option. Many of these tools are available for free and support Python development on multiple platforms. Third step, running your first Python program. Now that you have Python installed and a text editor or IDE set up, let's write and run your first Python program. Open your text editor or IDE and create a new file with a .py extension. You can start with a simple hello world program like this here, print hello world. Save the file and then run it by opening a command prompt on terminal or a terminal, navigating to the directory where the file is saved and typing python filename.py or python3 filename.py depending on your Python installation. If you get any type of error, you can always say python dash dash version or python3 dash dash version to check if it is installed at that particular location, or maybe it's missing in the path. Congratulations, you've successfully set up your Python environment and run your first Python program. You're now ready to dive into learning Python programming. Basic syntax. In this section, we'll cover the fundamental building blocks of Python syntax. Understanding these basic concepts will lay a solid foundation for writing Python code. First, let's go over variables and data types. Variables are used to store data in Python. You can think of variables as containers that hold values. In Python, you can create a variable and assign a value to it using the assignment operator, which is an equal to sign. Variables can hold different types of data known as data types. Some common data types in Python include integers, which are whole numbers without any decimal points. Example 5, -3, 1000. Floats, numbers that have decimal points. Example 3.14, 0.5, -2.718. Strings, sequences of characters enclosed in a single or double quotes. Example, hello in single quotes, world in double quotes. You can even have numbers inside it, but it will be a string if you add single quotes to it, like 1, 2, 3 inside single quotes. Booleans represents true or false values. Examples are true and false. Examples of some variables and data types are here, where I'm setting the age equal to 25, height equal to 5.11. Age is integer, height is float as you can see here, and name equal to John, which is a string, and is student equal to true, which is a boolean. Operators. Python supports various operators for performing operations on variables and values. These include arithmetic operators like plus, minus, multiplication, and division. There is comparison operators like double equal to, which is comparing equal if left is equal to right. Then there's not equal, then less than, greater than, less than equal to, greater than equal to, and also logical operators, which are and, or, and not, and many more. So here are some of the examples. If you see here, I've set up x equal to 10, y equal to 5 for arithmetic operation, saying sum equal to x plus y, which will give you a result of 15. You can create a variable difference and give x minus y. For product or multiplication, x times y. For quotient, you can x divide by y. This comparison operators is equal when I'm saying x double equal to y, which will tell me if it is true or false. Is not equal where I'm giving x is not equal to y, it's going to check and tell if it's true or false. Is greater than where x is greater than y. Is less than or equal to where x is less than or equal to y. So in the first case is equal, x is equal to y, it's not, because x is 10 and y is 5. For the second variable is not equal, it will be true because 10 and 5 are two different numbers. Is greater than, is x greater than y? Yes it is, because x is 10 and y is 5. Is less than or equal to, x is 10, so it's not less than or equal to y, which is 5. Logical operators. So if you see here, I am saying result equal to x is greater than y, which is x is greater than 0, which is true because x is 10, and is the logical operator, and I'm asking is y less than 10, which is true. So both are true, true and true, the result will be true. Comments. Comments are used to add explanatory notes to your code. In Python, comments start with the hash symbol and are ignored by the interpreter. Comments are useful for documenting your code and making it easier to understand for yourself and others. Here is an example where you can give the hashtag or a pound sign and say this is a single line comment. You can have a multi-line comment where you can use the triple quotes above, and you can just write your multiple lines of code below it, and to close it you give the double quotes 3 times below it. Example of using comments is here where I'm giving just writing example of using comment. I'm saying calculating the sum. So this kind of helps you in documentation. Next, I'm assigning value of 10 and I'm also explaining what I'm doing there. Y is equal to 20. I'm saying assigning value to y. And sum equal to x plus 5. And I'm saying in the comment that I'm calculating the sum. Understanding and mastering these basic syntax elements will enable you to write simple Python programs and manipulate data effectively. In the next sections, we'll explore control flow, functions, and more advanced concepts in Python programming. Control flow. Control flow statements in Python allow you to control the flow of execution in your code. They enable you to make decisions, repeat actions, and execute code conditionally. In this section, we'll cover some of the essential control flow statements in Python. First, conditional statements like if, else if, and else. Conditional statements allow you to execute different blocks of code based on whether a certain condition is true or false. The main conditional statements in Python are if, else if, which is the short of else if, and else. Here is an example. So first one, I'm assigning value is 10. Then I'm saying if x is greater than 0, print x is positive, which will be true. Since it's true, it's not gonna do anything else because the next one is else if x equal to 10, 0, print x is 0. Since x is 10, it already went through the first if loop, it's not gonna go there. So in this example above, the if statement checks if x is greater than 0. If it's true, the corresponding block of code is executed. If not, the else if statement checks if the x is equal to 0. And if that's true, its corresponding block of code is executed. If neither condition is true, the else block is executed. So you can run this program assigning different values to x in the first line and then see how it executes. Loops. There's for loop and while loop. Loops allow you to repeat a block of code multiple times. Python supports two main types of loops, for loops and while loops. For loop. A for loop is used to iterate over a sequence such as a list, tuple, or string, or any iterable object. So here I have an array or a list where of fruits where I have values like apple, banana, and cherry. And then I just run the for loop. I'm saying for fruit in fruits. So fruit is a variable that I'm creating for each item in the fruits array, and I'm printing the fruit. For here, what happens is the for loop iterates over each element in fruits list and prints it. While loop. A while loop is used to repeatedly execute a block of code as long as the condition is true. So for example, here you'll see the while loop prints the value of x as long as it is less than 5. The value of x is incremented in each iteration to avoid an infinite loop. So first I'm assigning the value of x is equal to 0. So I'm saying is x less than 5? It is true. So it's going to print 0. And then it's going to increment x plus equal to 1 increments the value of x. So it's going to be 1. Again, it's going to go back to checking while x is less than 5. It is because the value is 1. So it's going to print 1. And then 2, 3, 4. And when it increments the value to 5, it's going to check x is less than 5. It's not. So it will not print and get out of the loop. So it will print 0, 1, 2, 3, and 4. Break and continue statements. In addition to else if and else statements, Python also provides break and continue statements to modify the behavior of loops. Break statement terminates the loop prematurely and the control flow moves to the statement immediately following the loop. Continue statement skips the rest of the code inside the loop for the current iteration and proceeds to the next iteration of the loop. You can see how it is helpful. For example, here, in the first example here, the loop is terminated when I equals 5 using the break statement. In the second example, the continue statement skips printing even numbers, causing only odd numbers to be printed. So if you run through step by step, so first I'm saying for I in range of 10, which is from values up till 10. If I equal to 5, I break and I print the I value. I break and get out of the loop, or else I will print. So it will terminate when the value is 5, even though I'm setting the range up till 10. In the next second example, I'm saying for I in range of 10, if I mod 2 equal to 0, so what will happen is every time it is even number, it will it will not print it. It will continue and go to the next one. Whereas if it's odd number, it's going to print and keep on continuing till the end of the loop. Understanding control flow statements is essential for writing efficient and effective Python code. They allow you to make decisions, repeat actions, and control the flow of your program based on specific conditions. Functions. Functions are fundamental concepts in Python and programming in general. They allow you to encapsulate reusable pieces of code, making your program more organized, modular, and easier to maintain. In this particular video, we'll cover how to define and use functions in Python. First, defining Python functions. In Python, you can define a function using the def keyword followed by the function name and parenthesis containing any parameters the function accepts. The function body is then indented below the function definition. In this example above, you'll probably see we define a function named greet that takes one parameter name. Inside the function body, we print a greeting message using the provided name. If you run this, you'll probably have to call the function, which is the next section, and we'll go over that. But this will print hello, comma, whatever name you pass to this function. Now, calling functions. Once a function is defined, you can call it by using its name followed by parentheses containing any arguments you want to pass to the function. In the example here, you can see we can call the greet function that we wrote before and pass the argument Alice to it. This will print hello Alice to the console. Return statement. Functions in Python can optionally return a value using the return statement. This allows the function to compute a result and pass it back to the caller. So in this particular case, let's say if I'm calling the function add and passing it two values, it will return, not print. It will return to the variable or the control statement which actually called this particular function. So in the example here, the add function takes two parameters x and y, adds them together and returns the result. Default parameters. You can provide default values for function parameters, allowing the caller to omit them when calling the function. So I can create a function called as def greet name equal to world. So in this case, if there is no parameters passed or arguments passed, it will just print hello world and you don't have to pass a value to it. Keyword arguments. Python also supports passing arguments to functions by keyword, allowing you to specify which parameter each argument name corresponds to. So in the previous case, if I want to call the function greet and say the variable that I want to pass is name and I want to assign a value Bob. So if you have, this is helpful when there's multiple parameters and you want to specifically pass a parameter and skip the others. Variable number of arguments. Python allows you to define functions that accept a variable number of arguments using special syntax. So in this case, if you see here, the multiply function can accept any number of arguments which are accessible within the function body as a tuple named args arguments. Functions are a powerful tool for organizing and reusing code in Python. By defining functions, you can break down complex tasks into smaller, more manageable pieces and create modular and maintainable code. Data structures. Data structures are essential component of any programming language, including Python. They allow you to organize and manipulate data efficiently. In this section, we'll cover some of the built-in data structures in Python and how to work with them. So first one is lists. Lists are ordered collection of items which can be of different data types. Lists are mutable, meaning you can modify them after they have been created. You can access individual elements in the list using indexing. So if you see here, we have an example of fruits list which has apple, banana and cherry. You can print fruits of 0, which is the first index of the array. It will print out apple. If you say fruits of 1 equal to orange, what it does is it will change banana to orange because you're seeing that the first index, which is the second element in the list, is orange. So if you print it out, you'll see the output is apple, orange and cherry. Banana disappeared. Next, you can say fruits append banana, where What happens is if you have a list with three items, you can append another item to it and it will be added at the end of the list. So if you print it, you'll see output is apple, orange, cherry, and banana. Tuples. Tuples are similar to lists but are immutable, meaning you cannot modify them after they have been created. Tuples are often used to store collections of related data. So, for example, I'm creating a person tuple and I'm assigning values John, 30, and New York. So, if you see the difference here is it's not square brackets, it's rounded bracket. And you can access the elements by saying print person of 0 and you'll get output as John. You can unpack a tuple by saying that I have three elements in there. So, I can say variable name is the first element, age is the second element, and third city is the third element, and assign it to the person. So what it does is if you say print name, age, and city, it will print John, 30, and New York. So you can use this unpacked tuple variables anywhere you want in your code. Dictionaries. Dictionaries are unordered collections of key value pairs. Each key value pair in a dictionary maps the key to its corresponding value. Dictionaries are mutable and can be modified after creation. So if you see, dictionaries are assigned using the curly bracket. So if you see here, person equal to curly bracket, name is John, age is 30, city is New York. This is how you create dictionaries. Accessing elements, you can say from the person variable, give me the name and it will output John. I can say person age is 35 and it will update the age of this person to from 30 to 35. And if you output the person dictionary, you'll see that age has changed. You can say person gender equal to male. What it does is it will assign at one more variable inside the dictionary and assign the key as gender and value as male. And if you output it, you'll probably see it assigned at the end of it. Sets. Sets are unordered collection of unique elements. They are useful for removing duplicates from a sequence and performing mathematical set operations like union, intersection, difference, and symmetric difference. So here is an example. You use the same curly brackets, but you don't have key value pairs. And here I've assigned some values 1, 2, 3, 4, 5. I say add 6 to it, and if you print it out, you'll see 6 is printed. You say remove 3, and if you print it out, it will remove 3 from there. If you try to add any duplicates value, it will not take it. Understanding these built-in data structures and how to work with them is essential for writing efficient and effective Python code. They provide powerful tools for organizing and manipulating data in your programs. File handling. File handling is a crucial aspect of programming that allows you to read from and write to files on your computer. In Python, file handling is straightforward and flexible, allowing you to work with various file types and perform operations such as reading, writing, and appending data. In this section, we'll cover how to handle files in Python. First, opening a file. Before you can read from or write to a file, you'll need to open it. You can open a file using the open function, which takes two arguments, the file path and the mode in which you want to open the file. Example, you want to open it for reading, this is read mode, writing, write mode, appending, append mode. So you can call something like this. Here's an example where I'm saying open example.text and I'm saying passing the parameter r, which says I want it to open it for reading. Reading from a file. Once a file is opened, you can read its content using various methods. The most common method is read, which reads the entire contents of a file as a string. So you can say content equal to file, which is you opened before, file.read, and then print the content from it. Other methods for reading from a file include read line, which reads a single line from the file, and read lines, which reads all the lines of the file into a list. Writing to a file. To write data to a file, you'll need to open it in the write mode, which is W. If the file does not exist, it will be created. If it already exists, its contents will be overwritten. So you have to be careful. So here is an example where I'm saying file equal to open example.txt, the same file in write mode. Then I can say file write hello world to it, and it will overwrite to the existing component contents. If the file has not available, it will create that file and then write this text in there. Appending to a file. To append data to an existing file without overwriting its contents, you can open the file in the append mode. So if you don't want to accidentally overwrite something, you can use the A, which is the append parameter for appending a file. So you open the example text and pass A, and I'm saying file write. I'm saying write this data in a new line. So that's why I'm giving /n and I'm passing new content to it. Closing a file. After you're done working with the file, it's essential to close it using the close method to free up system resources. If you see here, this is how you close it. You just use that file variable and just say close. It's easy. Using the with statement. To ensure that a file is properly closed after you're done working with it, you can use the with statement, which automatically closes the file when you're done with it. So you can say with open example.txt and read as a read mode, and you say as file. So it's assigned the file opened to the file variable. Then you say content equal to file.read, so you read from there, and then print content. Using the with statement is recommended because it's more concise and ensures that files are closed properly even if an error occurs while processing them. File handling is critical skill for any Python programmer as it allows you to interact with external data sources such as text files, CSV files, and more. Mastering file handling techniques will enable you to build powerful and flexible Python applications that can read and write data to files effectively. Error handling. Error handling is an essential aspect of programming that allows you to gracefully handle unexpected situations and prevent your program from crashing. In Python, errors and exceptions are managed using try except blocks, which enables you to catch and handle errors that occur during program execution. In this section, we'll cover how to handle errors and exceptions in Python. First, errors versus exceptions. In Python, errors and exceptions are used to indicate that something has gone wrong during the execution of a program. Errors are typically caused by syntax errors or runtime errors, while exceptions are raised when a program encounters an unexpected condition that prevents it from continuing normally. Try except blocks. Try except blocks are used to catch and handle exceptions in Python. A try block contains the code that you want to execute, and an block contains the code that handles any exceptions raised by the try block. In the example here, the try block attempts to divide 10 by 0, which raises a 0 division error. The except block catches this exception and prints an error message. Multiple except blocks. You can use multiple except blocks to handle different types of exceptions separately. In the example here, you'll see the first except block handles a value error which occurs when trying to convert a string to an integer. The second except block handles a zero division error as in the previous example that we discussed. Take a look at the example. Finally block. You can use a finally block to execute cleanup code regardless of whether an exception occurs. In this example, the finally block ensures that the file is properly closed even if an exception occurs while reading its contents. If you see in the finally statement at the end, you say file.close. If anything happens in between the try the code and exception, the file will still be closed. So you are cleaning up the resources. Using except with no exception type. You can use an except block without specifying an exception type to catch any exceptions and all exceptions that occur in the try block. Here is an example where you're not specifying what type of except you want. While this approach can be convenient, it's generally recommended to specify the specific exception types you expect to handle to avoid catching unexpected errors unintentionally. By using try except blocks effectively, you can anticipate and handle errors gracefully, improving the robustness and reliability of your Python programs. Introduction to modules and packages. Modules and packages are essential features of Python that allows you to organize and structure your code into reusable units. Modules are individual Python files containing variables, functions, and classes while packages are directories that contain multiple modules and an optional special file named underscore underscore init underscore underscore dot py. In this section, we'll cover how to work with modules and packages in Python. So first, modules. A module is a Python file containing Python code. It can define variables, functions, classes, and other objects that can be used in other Python files. You can import modules in your Python scripts using the import statement. If you see here, example of importing a module where I'm saying import math. So in this example, we are importing the math module, which provides various mathematical functions. We then use the sqrt function provided by the math module to calculate the square root of 25 in the print function over there. Using aliases. You can use aliases to provide alternative names for modules, making them easier to reference in your code. So instead of calling math.square root in the previous one, we can just say we import the math module with the alias m. We then use the alias m to call the square root function from the math module. I know it's not a big deal, but it's a little bit sometimes helps. Importing specific items. You can import specific items, variables, functions, and classes from a module using the from keyword. In this example, we import only the square root function from the math module using the from keyword. We can then use square root function directly without specifying the module name. So you don't want to have to export the entire module, but just a function. Packages. A package is a directory containing one or more Python modules and an optional underscore underscore init underscore underscore dot py file. The underscore underscore init underscore underscore dot py file can be empty or contain initialization code for the package. This is how a package looks like, where you have a my package and you have the init file and then you have other modules in there. To import modules from a package, you can use the dot notation. So from the above package, I can say import my package dot module one. So you're just importing the first one. So in this example, we import the module one and then module two modules from the my package and call functions or classes defined in these modules. Subpackages. Packages can contain subpackages, which are packages within packages. You can import module from subpackages using nested dot notation. In this example here, we import the module 3 module from the subpackage called as subpackage of my package and call functions or classes defined in this module. Modules and packages are powerful tools for organizing and structuring your Python code, allowing you to create reusable and maintainable code bases. By using modules and packages effectively, you can improve code organization, reduce duplication, and enhance code usability in your Python projects. Introduction to Object Oriented Programming, or OOP. Object Oriented Programming is a programming paradigm that revolves around the concept of objects, which are instances of classes. OOP enables you to model real world entities as objects and define their behavior through methods and attributes. In this section, we cover the basic principles of OOPs in Python. Classes and objects. A class is a blueprint for creating objects. It defines the attributes like data and methods like functions that the objects of the class will have. An object is an instance of a class representing a specific entity with its own state and behavior. Check out this example. In this example, we define a dog class with class attributes species and instance attributes name and age. We also define an instance method bark that represents the behavior of dog objects. Creating objects. Once a class is defined, you can create object instances of that class using the class constructor method underscore underscore init underscore underscore. In this example, we create two dog objects, dog1 and dog2, with different values for the name and age attributes. Accessing attributes and methods. You can access the attributes and methods of an object using dot notation, object.attribute, or by calling the method directly on the object by calling object.method and parenthesis. In this example, we access the name and age attributes of the dog1 and dog2 objects, as well as call the bark method on the dog1 object. Inheritance. Inheritance is a key feature of OOP that allows you to create new classes, derived classes, based on existing classes, which are base classes. The derived classes inherit attributes and methods from the base class and can also have their own additional attributes and methods. In this example, we define a golden retriever class that inherits from the dog class. The golden retriever class has its own additional methods like wagtail. While inheriting the name, age, and bark methods from the dog class, it has its own wagtail function which can be called. So if you see at the bottom when we are printing golden.name, that is not defined here but in the dog class. Encapsulation and abstraction. Encapsulation is the bundling of data, which is the attributes, and methods, which are the functions that operate on data into a single unit, which is a class. Abstraction is the concept of hiding the complex implementation details and showing only the essential features of an object. By encapsulating data and methods within classes and using abstraction to hide implementation details, object oriented programming promotes modularity, reusability, and maintainability of code. Object oriented programming is a powerful paradigm for organizing and structuring code, enabling you to build complex systems and applications with ease. By understanding and applying the principles of object oriented programming, you can create more robust, scalable, and maintainable Python programs. Next steps. Congratulations, you have completed this introductory course on Python programming. By now, you should have a solid understanding of the core concepts and features of Python, including variables, data types, control flow, functions, file handling, modules, packages, and object oriented programming. Python is a versatile and powerful programming language that is widely used in various fields, including web development, data science, machine learning, artificial intelligence, and automation. With the knowledge you have gained from this course, you're well equipped to start exploring these areas further and building your own Python projects. Here are some next steps you can take to continue your Python journey. First, practice, practice, practice. The best way to improve your Python skills is through practice. Start by solving coding challenges on platforms like LeetCode, HackerRank, or Code Academy. You can also work on small projects to apply what you have learned. Next, dive deeper into specific areas. So Python has a vast ecosystem with specialized libraries and frameworks for various domains. Depending on your interest, you can explore topics such as web development, use Django or Flask, or data analysis where you can use Panda, NumPy, or go to machine learning and use scikit-learn and TensorFlow and more. Read documentation and tutorials. Python has excellent documentation available on its official website, which is docs.python.org. You can also find numerous tutorials and guides online for learning specific topics or libraries in Python. Join communities and forums. Joining Python communities such as forums, online communities, and local meetups can be a great way to connect with other Python developers, share knowledge, and seek help when needed. Contribute to open source projects. Contributing to open source project is an excellent way to gain real world experience and improve your coding skills. You can find open source Python projects on platforms like GitHub and GitLab. Remember, learning Python is a journey and it's okay to encounter challenges along the way. Stay curious, keep exploring, and don't be afraid to experiment with new ideas and concepts. With dedication and persistence, You'll continue to grow and evolve as a Python programmer. Good luck and happy coding.